Alright, so today we're going to do rational expressions where there's more than two rational expressions. We're going to do three, okay? It's not that bad, but I think it'd be good just to practice on a Friday. Alright, so you do it the same way you do, we've done all our problems, okay? So multiplication we know is fine, alright? But division, we're going to have to do that keep, change, flip. Okay, so you still keep this one the same too because it's multiplication. So now we're going to have negative 4 over x minus 4 times x squared plus 17x plus 70 over x squared plus 3x minus 28. Change division and multiplication. Flip that last fraction. All right, and that's, now you're ready. Now it's all multiplication. And so we know that when we multiply, we just have to factor everything. So the negative 4 over x minus 4 can't be factored. That's it. Okay? Unless you want to say negative 1. Let's do that. Let's say negative 1 times 4 to keep up with what we've been doing. So 4 times negative 1. Okay? Then, well, let's just leave it at 4. Negative 4. Okay, so then I need to factor this guy right here. You can use Desmos or you can do it in your head. So it's going to be x plus 7, x plus 10, all over. Same thing for this one. All of these can be Desmos factored. Okay, it'd be x plus 7, x minus 4, then times, factor that numerator, which is going to be x minus 4, x minus 4. Now, remember when I told you that leading coefficient's negative to always pull it out? So we're going to pull out a negative 1, and I get x plus 10. Okay? I told you that in a previous video. When your leading coefficient's negative, pull that negative out and see what happens. Okay? So now that I've got it in factor form, I can cancel out all my like factors on top and bottom. So I have an x minus 4 and x minus 4. I have another x minus 4 and another x minus 4. So since there was two x minus 4s on top and two x minus 4s on bottom, you can cancel both of them out. I got an x plus 7 and an x plus 7. And see, since I took that negative 1 out, I've got an x plus 10 and an x plus 10. Okay? So then you smush what you have left. All I have left is a negative 4 on top and a negative 1 on top. Well, negative 4 divided by negative 1 is going to be a positive 4. So this actually reduces down to a number, which is kind of cool. It started out super huge, and now it's just a number. All right, I'm going to do two more. So this one, you do the same thing, okay? There is a division problem right here. So I do need to do the keep, change, flip, okay? And you can say keep, change, flip if you want to on this one, because this is multiplication, so it's fine. So we're going to keep that first fraction the same. Times, keep the second one the same too. Change division and multiplication, and then flip that last fraction. Okay? Alright, so the first one looks like it's going to be a GCF factor. Let's see if 192 can be divided by 3. And it can. So 192 divided by 3 is actually 64. So I come over here, and I'm going to pull that 3 out. And I get x squared minus 64. Well, I want to stop there too, because it's x squared. You know you might be able to factor it some more. Well, 64 is a perfect square. What's the square root of 64? Plus or minus 8, right? So that's a perfect square binomial, and I can change that to 3 times x plus 8, x minus 8. Okay? The bottom one's written differently. If it's ever written differently, go to Desmos. Okay, I've typed it in 64 minus x squared. Is it factorable? It is, because look, there's a negative 8 and a positive 8. So you can factor that. And that's also, even though it's written backwards, it's still x plus 8, x minus 8. okay? Times, probably gonna run out of room. The 4 is not factorable. Now the denominator is, that's gonna be x plus 8, x plus 8, okay? Uh-oh, sorry guys. Here we go. Let's see, is it still recording? Alright, so then we're gonna factor this top. I'm gonna come up here. Okay, I ran out of room. And so I'm going to factor the x squared plus 18x plus 80. That's going to be an 8 and a 10 over x plus 10. Okay, so now I'm going to cancel out my common factors. Alright, and just remember this is a top still and this is a bottom. So there's an x plus 8 on top and x plus 8 on bottom. X minus 8, x minus 8. Now remember this is a top, so there's an x plus 8, another x plus 8, x plus 10, x plus 10. So the only thing left, let's see, did I do that right? Oh, this is an x plus, let's see, 1, 2, yeah. So what I have left is a 3 and a 4 on top, which is a 12, and then I have an x plus 8 on the bottom. So that is my final answer. Put it up here. Okay. Alright, so last one. Okay. So this one is all multiplication, so we don't have to do any keep, change, flip. We can just go straight to factoring and then simplifying. So, saves us a step. So we're going to factor this numerator first. Okay, 35 is only going to be 7 and 5. So it's going to be x plus 7, x minus 2, because 7 minus 2 is, 5, I'm so sorry. So 7 minus 5 is positive 2, and then 7 times negative 5 is negative 35. I told you if you have a negative as your leading coefficient, factor that negative 1 out. So I get an x plus 5, okay? Times, this one right here has a GCF factor. Okay, so we're going to come over here and do a little side factoring with it. So everybody's divisible by 4, so I'm going to pull a 4 out. Everybody also has an x, so I'm actually going to pull a 4x out. And I'm left with x squared plus 6x plus 5. That is factorable. 4x times x plus 5 and x plus 1. So now I'm going to take this and put it down here. Okay, the denominator is, I also can pull an x out of that one. See how they all have x's? So that's actually going to be x squared plus 12x plus 35. I can factor this. Okay, that's 7 and 5 again, but each one's going to be positive because 7 plus 5 is 12, and then 7 times 5 is 35. Times, factor this one. Let's see, 40 is going to be 8 and 5. So x plus 8, x plus 5. Okay, 5 times 8 is 40. 8 plus 5 is 13. Alright, the denominator is also factorable. And that's going to be an x plus 1 and an x plus 8. Okay, now we get to cancel our factors out. Let's do this. So, I usually start up here. There's an x plus 7, x plus 7. No x minus 5. Okay, there is an x plus 5. There's actually 2 of them. Well, 4, so you can mark out 2 sets. There's an x plus 1, x plus 1, x plus 8, x plus 8. There's an x and an x, and that's it. So we smush the top, which is going to be 4x minus 5, and then the denominator has that negative 1 still. Well, you can just say 4 divided by negative 1 and get negative 4x minus 5 as your answer. Okay? Alright, so that is what your Delta Math is on today. There's 5 problems, so let me know if you have any more questions. Alright, bye guys.